Have you ever wondered why the ocean is salty? It's a question that's simple on the surface, but the answer is more complex than you might think. You see, the ocean's salinity isn't just about a particular taste, it's a key factor in our planet's health and climate. Let's think about this for a second. When we say the ocean is salty, what we're really saying is that about 3.5% of the ocean's weight is made up of salts. And the primary culprit? Sodium chloride, which you might know better as table salt. But it's not just about sprinkling a little salt into the water. No, the saltiness of our oceans is a grand global phenomenon that's been billions of years in the making. So, what makes the ocean so salty? Let's delve into the science behind it. The saltiness of the ocean, or its salinity, has a few sources. Now let's dive into the heart of the matter. One of the primary sources of ocean salinity is, you guessed it, rivers. These winding water bodies, large and small, act like the Earth's circulatory system. They carry various minerals and salts from the land into the ocean. Imagine every time it rains, the rainwater washes over the soil and rocks, eroding them gradually. This process extracts ions, or electrically charged atomic particles, that the water carries along its course. These ions are the building blocks of salts. So, when the river finally meets the sea, it delivers its salty payload, contributing to the ocean's salinity. Now, let's go deeper, literally. Beneath the ocean's surface, volcanic activity plays a substantial role in the salinity levels. Submarine volcanoes and hydrothermal vents release molten minerals directly into the ocean. These minerals then dissolve into the surrounding seawater. For instance, when a volcano erupts underwater, it spews out lava rich in salts and minerals. As the lava cools and interacts with the seawater, it releases these salts, further salting our seas. But here's the fascinating part. The ocean doesn't keep getting saltier and saltier with each passing river or volcanic eruption. The salinity of the ocean, although varying in different parts, remains relatively constant on a global scale. It seems like there's a delicate balance at play here. But what could possibly be keeping this balance in check? Is there some kind of a salt bouncer at the ocean's door, letting in just the right amount of salt and turning away the excess? Well, not exactly, but the truth is no less intriguing. And to fully understand this, we'll need to explore the concept of the salt balance in our next scene. But the story doesn't end here. The ocean doesn't keep getting saltier and saltier. Why is that? Let's find out. You might think that with all this salt pouring in, the ocean should be getting saltier. But that's not the case, and here's why. Our oceans have a fascinating ability to maintain a salt balance. This is due to a few key processes that we'll delve into right now. First, let's talk about evaporation. As the sun heats the ocean, it causes the water at the surface to evaporate, leaving behind the salt. This increases the salinity of the ocean water. However, this process is balanced out when the evaporated water returns to the ocean as rain, which is fresh water, thus diluting the salt concentration. Next, we have the formation of sea ice. In the polar regions where the ocean water freezes, the process of freezing actually excludes salt, leaving behind saltier water in the ocean. But when this ice melts during warmer seasons, it releases fresh water back into the ocean again, diluting the salt concentration. Lastly, let's not forget our marine organisms. These sea-dwelling creatures play a crucial role in maintaining the ocean's salt balance. For instance, shell-building animals and plants like corals and some types of plankton absorb salt ions from the water to build their shells and structures. When these organisms die, their shells sink to the seafloor, and over time, become part of the sediment, effectively removing salt from the ocean. So, while rivers and underwater volcanic activities constantly feed salt into the ocean, these balancing processes ensure that the overall salinity remains relatively stable. It's a dynamic, ever-changing system, yet it maintains an equilibrium. In essence, the ocean isn't just a big bowl of salt water, it's a complex self-regulating system where processes of adding and removing salt are continuously at play. And this beautiful balance of nature is what keeps the ocean's saltiness in check. So we've learned about how the ocean gets its salt and maintains the balance, but why is this salinity so important? Well, stick around as we dive deeper into this salty tale. The ocean's salinity isn't just a curious fact, it plays a vital role in our planet's health. So, let's dive deeper into how this works. You see, salinity, along with temperature, influences the density of seawater. Warmer or less salty water is lighter and rises to the surface, while colder or saltier water is denser and sinks. This difference in density creates a global oceanic conveyor belt, a constant churning cycle that pushes water from the surface to the depths and back again, circulating heat around the globe. Imagine it as a giant underwater expressway, moving heat from the equator to the poles and cold from the poles back to the equator. This circulation regulates our planet's climate, distributing heat and, in turn, influencing weather patterns. If this conveyor belt were to slow down or stop, it could trigger significant shifts in climate, potentially leading to more extreme weather events or even a new ice age. But the role of salinity doesn't stop there. It also has a profound influence on marine life. The concentration of salt in the water impacts where different organisms can live and thrive. Some marine creatures prefer the saltier waters of the open ocean, while others are better suited to the less salty coastal waters. In the open ocean, where salinity is higher, you'll find creatures like the swordfish, marlin, and certain species of shark. Closer to the coast, where fresh water from rivers dilutes the seawater, you'll find species like the Atlantic salmon, which can adapt to both fresh and saltwater environments. Salinity also influences the growth of phytoplankton, the microscopic plants that form the base of the ocean food web. These tiny organisms not only feed countless marine creatures but also produce half of the world's oxygen. Without the right salinity, their growth could be stunted, disrupting the food web and the oxygen we breathe. From influencing global climate to shaping marine ecosystems, the ocean's salinity is a small detail with a big impact. So we've taken a deep dive into understanding why the ocean is salty. We've traversed the journey of a single grain of salt, from its origins in the Earth's crust, carried to the ocean by rivers and rain. We've seen how the ocean's vast salt content is maintained in a delicate balance by natural processes: evaporation, precipitation, ice formation, and the movement of sea currents. The ocean's salinity is not just a curious fact for trivia night, it's a critical component of our planet's health and climate. It drives ocean currents, affects marine life, and even influences our weather patterns. In essence, the salt in our oceans is a testament to the intricate and interconnected systems that make life on Earth possible. It's a story of the planet's past, present, and future, written in the waves. So next time when you taste the salt in the ocean, remember it's not just about taste, it's a tale of our planet's health and climate.